Hello students, good morning to one and all. I am Professor Saili Rathod from International Center of Excellence in Engineering and Management, ICEEM Aurangabad. Today I am here to present a video lecture of electrical measuring techniques. This is the video number 12 of the video lecture series of EMT, and today's topic that we are going to cover is extension of range of ammeter and voltmeter by using current transformer and potential transformer. As in the previous lecture, we have seen the similar topic, that is extension of range of ammeter and voltmeter, but in that method we have not used current transformer and potential transformer. We have used the resistance, that is shunt resistance, which is connected in parallel with the ammeter, and it is connected in series with voltmeter for the purpose of range extension. But in some measuring instruments there is a need of higher range of outputs where we cannot use the shunt resistance, or we cannot use the resistance in series or parallel for range extension. So for that purpose we need current transformer and potential transformer. So in today's lecture we will see why do we use CT and PT and what is the actual process or the circuit which we are using for the extension. So before moving on today's topic, we will have a review on what we have seen yesterday. So here you can see that we have seen the extension of range of ammeter and voltmeter. The first figure shows that if you want to increase the range of ammeter, then what we have done, we have connected a shunt resistance in parallel. This resistance is of a very low resistivity. So using this low resistance in parallel with ammeter, we have extended the range of ammeter. And in the second figure you can see we have connected a high resistance in series with the voltmeter. So by this process we have extended the range of the voltmeter. Now here we can see that where we have to use shunt or multipliers and where we have to use the CT and PT. Okay, so first point says that the shunts and multipliers are used to extend the range of moving coil ammeters and voltmeter respectively. Okay, it means in the previous lecture, the methods we have seen for range extension that we can use only for moving coil ammeter and voltmeter. Whereas in the case of moving iron ammeter, okay, moving iron means MI instruments of ammeter, for the range up to 0 to 250, shunts can be used. Means for the MI ammeters, for lower range we can use the shunts, but for the higher range we cannot use the shunt resistance. So for that purpose we have to use the current transformers. Okay, so friends, please remember these points very clearly, that for moving coil we can use shunt and multiplier. For moving iron ammeter, for lower range we can use shunt, but for higher range we have to use current transformer. And also in the case of moving iron voltmeters, for the range up to 0 to 750, that is for lower range we can use multipliers, but for the higher range we have to use the potential transformers. Means where is the need of CT and PT, it is only needed for the moving iron instruments, that is moving iron ammeter and voltmeter, and also in this MI instruments for the higher range only we have to use CT and PT. Okay, so everybody should be able to differentiate between all these instruments, and the concept should be clear in everyone's mind that where we have to use this shunt multipliers and where we have to use this CT and PT. Okay. Now moving ahead, for we will see the need for current transformer and potential transformer. The shunts cannot be used to extend the range of moving iron AC ammeters accurately. Okay, as we cannot use this moving iron instruments, shunts cannot be used for this moving iron instruments. Why? Because it are not accurate, and we know that in measuring techniques the accuracy should be high. So it is because the division of current between the operating coil and the shunt, which varies with frequency. In practice, the range of moving iron In practice, the range of moving iron AC ammeters are extended by one of the following methods, means either by CT or by potential transformers. So now we will see how to extend the range of ammeter by using coil turns. We can extend the range by changing the number of turns of the operating coil. For example, suppose that full scale deflection is obtained with 400 ampere turns. For full scale reading with 100 ampere, the number of turns required would be 400 divided by 100, that is 4. Similarly for full scale reading with 50 ampere, the number of turns required is 400 by 50, that is 8. Thus, the ammeter can be arranged to have different ranges by merely having a different number of turns on the coil. Since the coil carries the whole of the current to be measured, it has a few turns of thick wire. The usual ranges obtained by this method are from 0 to 250 ampere. Okay, so what does this point says? That if in an ammeter, if you want to read the value till 400 ampere, but the capacity of this ammeter is only of 100 amperes. So what we can do, we can increase the number of turns, so that if you are using the number of turns equals to 4, then the 100 ampere capacity will be multiplied by 4, and it will give the full scale deflection at 400 amperes. So depending upon, here we have divided 400 by 100 to get how many number of turns are required for the 400 ampere. So depending upon what you want as the output, you can increase or decrease the number of turns for the range extension. Means for range extension you need to only increase the number of turns. Okay, so this is one method for the range extension of ammeter. Now we will see the next method of range extension of ammeter by current transformer. Okay, now for ranges above 0 to 250 ampere, a current transformer is used in conjunction with 0 to 5 ampere moving iron AC ammeter as shown in the figure. The current transformer is a step-up transformer, that is number of secondary turns is more than the primary turns. Usually the primary windings of the transformer contains a single turn or at a most of few turns. The primary of the transformer is connected in series with the load and carries the load current. The AC ammeter is connected across the secondary of the transformer. Now from the figure we can see here the high voltage power source is connected to the left hand side and the load is connected to the right hand side. It means the actual voltage, that is load voltage, which can be calculated across this load is equals to VL. Now we have used the step up transformer. It means the primary and the secondary both have a different number of turns. Here it is 10:1 ratio for the current transformer. So it is used to increase the capacity of this ammeter If the 10 is to 1 ratio means if the primary is having capacity of 3 ampere, then the secondary will multiply it by 10 and it will give the output as 30 ampere. Means the capacity of this ammeter is increased from 3 to 30 ampere. Since in figure the current transformer ratio is 10 is to 1, it means that line current is equal to 10 times the reading on the AC meter. Therefore, load current IL equals to 3 into 10, that is 30 ampere. Okay, so here the concept should get clear to everyone. That is, for increasing the capacity of ammeter, we have used the current transformer, which is a step-up transformer. Step-up transformer means what? Here you can see the number of secondary turns is more than the primary turns. Means if the primary is having 3 turns, the secondary will have that multiplied by 10, means 30 turns. Okay, now the next method of range extension, that is range extension of voltmeter by potential transformers. The same figure we can refer for this. As you can see here, potential transformer of ratio 20 is to 1 is connected to the circuit. The range of a moving iron AC voltmeter is extended by connecting a high resistance multiplier in series with it. Okay, so this point is explaining the method we have seen in the previous lecture. That is, for lower range we have used the shunt multipliers, but for the ranges higher than 0 to 750 volt, where power is wasted in the multiplier, would be excessive. Means power can be wasted if we use the multiplier, so it should not be feasible for us. So what we have to do, we have to use a potential transformer. A 0 to 110 volt moving iron AC voltmeter is used in conjunction with a potential transformer as shown in the figure. Okay, now from this figure you can see we have used a potential transformer whose ratio is 20 is to 1. It is a precision step down ratio. The voltage which is connected, means the range of this voltmeter is 100 volt, but we need to extend the range of this voltmeter, so we have connected a potential transformer. The potential transformer is a step down transformer, that is, number of primary turns is more than the secondary turns. Now what is the difference between the previous method and this method? In the extension of range of ammeter by using current transformer, the transformer which we have used, it was a step up transformer, and the transformer which I have used in the potential transformers is a step down transformer. The primary of the transformer is connected across the load across which voltage is to be measured. The AC voltmeter is connected across the secondary. Since in figure the potential transformer ratio is 20 is to 1, the load voltage is equal to 20 times the reading on the AC voltmeter. So load voltage equals to VL equals to 100 into 20. As we know that the capacity of the voltmeter is 100, so we can multiply 100 by 20 to get the 2000 voltage. Means the range is extended up to 2000 volts. So this is the another method for range extension of voltmeter. So friends, we have studied up till now range extension of voltmeter and ammeter. We have seen 4 techniques. First one was by using shunt resistance. Second one was by using multipliers. Third one was by using current transformer. And fourth one is by using the potential transformers. These are the 4 techniques for the range extension. So in the next lecture we will see you with the new topic. So till that, keep studying. Thank you so much.